Hey everybody, this is the lesson on modeling regression 3.6. Very easy lesson. You just need to print this out if you haven't already, and then get your calculator, and pretty much it's all going to be done on the calculator. These were all guided practice problems that are found on page 201 in your book. So if you wanted to follow along, you didn't have the sheet, it's on the guided practice of 201. So there's three types of regressions that they're going to talk about in this section. There's the exponential regression, and looks like this. You're going to get statistics, scatter data that have this exponential curve to it. And the calculator will ask you to find the a times b to the x. So you would need to find the a and the b. And again, your calculator does all that work for you. You just have to write it correctly. If it asks for a logarithmic regression, logarithmic, remember, is the inverse of exponential. So it has this curve to it. Our book actually calls it the ln regression. Be careful there. The ln, not the lin, not the lin reg. The ln regression is the same as logarithmic. So for this one, you would choose y, or the equation they give you is y equals a plus b ln x. And again, you would input the a and the b. And the third kind is what's known as logistic regression or logistic growth model. And the formula is right here. Hopefully you can see it. You would actually have to input, since this is f of t, you would have to input the c, the a, and the b. The t you would leave open, and the e is that number that we're all we love to look at and use in our calculator all the time. I don't know what I'm saying. Moving on. Logistic growth regression, let me just explain why it's used. What ends up happening is if we're trying to find the growth of something over the time is your x-axis. It eventually flattens out due to population, food sources, things like that. So you don't really get this curve that keeps going up and up like an exponential regression. It usually flattens. So they're going to tell you when to use each one of these models, which is just awesome. So I'm going to start off and do one of each, and then you can do your 3 problems of homework. So this one says the internet experienced rapid growth in the 1990s. The table shows the number of users in millions for each year during the decade. Use exponential regression, so it's telling us, to model the data. Then use your model to predict the number of users in 2008, and let X be the number of years after 1990. So you're not going to type 1991 in your calculator. You're going to type 1, 2, 3, because it's the number of years after 1990. Now, I've already input this into my calculator to save myself some time here. If you don't remember how to input it in your calculator, you just go to Stat and Edit, and you put it into List 1 and List 2. I have something in L3 and L4, which I'll use for another example in a minute. So we are going to go to Stat, Calc, and we're going to go down to expreg, exponential regression. That's what it says to use. So look at right there, number 10, expreg. And you hit Enter. And my X list is L1, my Y list is L2. So we're going to hit Calculate. And it even gives you the formula Y equals A to B times B to the X. So our A is 0.44. So Y equals A times B to the X, where A is, I would go to at least 3 decimal places. And B is 1.696 to the X. And there you go. There's your exponential regression, all based off of the calculator. I will say that we need to do, let's see, I think we have to predict the number of users in 2008. So what am I going to put in for X? Okay, remember these are years after 1990. So my prediction for 2008, I would need x to equal 18 for the year 2008. So y equals 0.443 times 1.696 to the 18. 0.443 times 1.696 to the power of 18. And I get 5,971. That was 5,971.3 people? There's only 5,000 users of internet? No. Remember back up here, it says users in millions. 5,000 million. 5,000 million is actually 5,971.3. It's actually 5 billion. That's what that is, users. And that's how you do it. Pretty easy. All right, let's try number 2. Life expectancy. The table shows the U.S. average life expectancies according to their birth year. Use logarithmic regression to model the data. Then use the function to predict the life expectancy of a person born in 2020. Let x be the number of years after 1900. So this would be 50 when I put it in my calculator, 60, 70, 80. Again, you want to make sure you read that. Now, I put this into a different calculator just because I didn't want to keep using the same one. My battery is dying on this one. But I went to Stat, Edit. As you can see, my list 1 and list 2 are complete. So I'm going to go to Calc, and I want to do a logarithmic. Now, be careful here. It has this word logistic, which everybody thinks is logarithmic. That's not. Logarithmic is ln reg. ln reg. So you hit ln reg. My list 1 and list 2 are there. We calculate it. And it even gives us the a and the b and the ln x. So my y equals a plus b ln x, where my a is 15.09, my b is 13.38 ln x. There's my logarithmic regression. Hey, and based off of this, do you remember, is that a good regression? If I have an r squared of 0.97 or an r of 0.98, remember you want your r squared to be closer to 1. And it is, that's pretty good. 0.97 this is a pretty accurate model. All right. So now I want to, let's see, we're going to predict it for a person born in 2020. So how many years after 1900 is that? So let x be 120 years after. So we would say y equals 15.09 plus 13.38 ln of 120. So what do we got here? 15.09 plus, I'd like to put extra parentheses, 13.38 ln 120, close, 79.146. So about 79 years old. If they were born in 2020, they live to be about 79 years old. Pretty easy. All right, well, last one. This is about fish, and they are using a logistic regression to model the data in the table about a lake's fish population. Use your model to predict the limit to the growth of the fish population. So again, I put this in my calculator. I actually put it in L3 and L4. And And so I'm going to go to Stat Calc Logistic Regression, which is logistic. And I actually have to change it. I don't want L1, I want L3 and L4. If you don't know how to do it, don't worry. Just retype it into L1 and L2. And give it a minute. She's having a hard time. There she is. Okay. Now look, they give you the formula again at the top, which is awesome. So we move this over just to write what the formula is. Y equals C over 1 plus AE, and the E is to the power of negative BX. Okay, so I'm going to input A, B, and C. So Y equals, my C is 8,498.86 divided by 1 plus my A is 64.7 E to the negative B power to the negative 0.339, and then put a little X next to it. And then if it asked us to predict something after, 24 months, maybe 48 months, then I put a 48 right here. But that is the logistic model. All right, hopefully that was an easy lesson. Have fun. Bye-bye.